Another popular application of stacks is in evaluating arithmetic expressions, right? So I'll explain you a few terms and what they mean. What are the pros and cons of each of these, right? So before we go into it, let's understand, if you have an expression like this, right? If you have an arithmetic expression like this, where you have a plus b multiplied by c, right? This is a very simple arithmetic operation where you have two operators. So what is an operator here? An operator is your addition and multiplication and division and subtraction. And you have three operands. What are operands? Operands are the variables that you have, are the numbers that you have. In this case, A, B, and C are your operands, right? This is simple terminology that will help you understand. So A, B, C are operands. Plus and multiplication star are basically your operators. And your operators, whether it is plus, star, or multiplication, division, and subtraction, all of them are two parameter operators, right? Which means they require two parameters. You can add two numbers or you can subtract one number from the other. They're not unary operators. For example, if you have sin x, right? Sin x is called a unary operator because it only requires one parameter to operate on, while typical arithmetic operators like plus, star, or multiplication, addition, multiplication, division, and subtraction need only they need two parameters, or they need two operands to operate upon, while there are these unary operators like sin x which require only one operand. Okay, this is important to understand. Imagine we are evaluating arithmetic expressions where we have only two parameter operators. Okay, let's assume that. Now, if somebody gives you this, okay, suppose you are writing some program, and in the programming language you write something like this with A, B, C being three different variables with some values in them. Now here, so this notation is called infix. Why is it called infix notation? Infix is what we typically use. It is called infix notation because look at this very simple thing, A plus B. In infix notation, I place the operator, this addition symbol, in between. So the word in here basically means I place it in between the operands that I have. That's why it's called the infix notation. So there is something called as a prefix notation. Okay. And there is another thing called as postfix notation. I'll explain you these notations in more detail as we go, but let's just understand it from this very, very simple example, right? So this is, if you have just two operands and one operator, A plus B, this is your infix. This is what we're typically used to writing because you place both of them and in between them, you place your symbol, right? Or your operator. So prefix says, instead of placing it in between, let's move it to the front. So prefix says AB. In prefix, the operator is there pre basically means before. It is there before A and B. In postfix notation, you have A, B, and plus, right? Note here that plus is after or post, right? In other words, if your operator is in between your operands, it is called infix. If your operator is before your operands, then it is called prefix. If your operator is after or post your operands, it is called as postfix. Very simple. So prefix is also called as Polish notation. I'll tell you what are the advantages, why even are learning about postfix and prefix in the next couple of minutes. This is also called as the Polish notation, right? So postfix is also called as the reverse Polish notation. It is also called as the reverse Polish notation, right? Some very simple terminology here, don't worry about it. Now, typically, let's look at infix. Let's look at what are the disadvantages of infix and how prefix and postfix can fix some of these, okay? That's a tongue twister, okay? So let's take a simple expression like this, A plus B multiplied by C. When I do this, typically, if I don't parenthesize it, if I don't place any parenthesis, when I write infix, when I write an infix expression like this, I have to take care of precedence. I have to take care of precedence of operators, right? Precedence of operators. What does precedence of operators mean? We all learnt about BODMAS rule as high school kids, right? So precedence basically means that we first we finish this multiplication, because multiplication comes before addition. And then whatever is the resultant that we get from this, that is added to A. So this is equivalent to, when I parenthesize it, this is equivalent to A plus B star C. Right? This is the actual correct order of precedence of operators. Right? While this is true, it is not equivalent to A plus B multiplied by C. Right? This is incorrect. Remember, this is incorrect and this is correct, because of the BODMAS rule that we apply for precedence of operators. Suppose if I'm just given the infix expression, right? If I'm not given the rules of precedence, right? BODMAS basically tells us the rules of precedence on which operator should be applied before which operator. If I'm just given this without parenthesis, there is a lot of confusion here if I don't know the rules of BODMAS. On the other hand, if I have parenthesis, see, the moment I parenthesize this whole thing, this is a fully parenthesized expression, right? In this, there is no confusion, because first I'll evaluate everything which is there in the parenthesis, then I'll take its value, then I'll evaluate this parenthesis. So infix notation, right? When we use any expressions in infix, parenthesizing it clarifies what is the order of precedence, right? So when your expression is given in infix, there is some ambiguity, there is some confusion on which operator must be performed earlier, if you don't know the BODMAS rule, right? But the best way to avoid that problem is to parenthesize everything. If you parenthesize everything, there is no more confusion here, right? So this is one of the drawbacks, that only by parenthesizing an expression, right, you're able to convert everything. You're going to remove the ambiguity or the confusion. Now let's look at prefix for the same thing, right? For the same expression, what would the prefix look like? Suppose if I gave you a prefix, let's say, okay, let's say my prefix is like this, right? Plus A star BC. Imagine this is my prefix expression, right? If this is my prefix expression, as long as every operator that you're using is a 2-parameter operator, right? What am I using? I'm using plus and star here. Both of them are 2-parameter operators, right? As long as all the operators are 2-parameter, I don't require parenthesization if I'm using a prefix notation. I'll tell you why. Look at this. What does this mean? The moment you write this, it is clear for me, because look at the prefix. What does prefix mean? The operator exists before the operands, right? What does this mean to me? This means I have to multiply. See, this operator here basically says I have to multiply B and C. Whatever is the resultant, I have to add that to A. So this is exactly equivalent to A plus B star C. There is no confusion here. On the other hand, imagine if I have something like this. If I have A, B, right? Imagine if I have something like this, right? And okay, so I have these two, and then I have my C, I have my star here. Let's assume this is my prefix. What does this prefix tell me now? Let's go and understand this prefix. I have an operator here. This operator, I still don't know what to do. So this operator says A and B must be first added. So this is equivalent to A and B must be first added. So A plus B, right? And then there is a multiplication here. So the resultant of this is now to be multiplied with C. So this is to be multiplied with C, right? So when I wrote something in prefix notation, see, when I write it in infix notation like this could be interpreted as this or this if I don't have parenthesis and if I did not know the precedence of operators. This could be interpreted in both ways, right? I can place parenthesis the way I want. But the moment I wrote the same thing. The moment I wrote in prefix, this expression will have a different prefix as compared to this expression, right? So when I have prefix notation, I do not need parenthesization. I do not need parenthesis. I do not need parenthesis, and there is no confusion here, right? I do not need parenthesis. I did not know, because the precedence of operators, because in prefix notation, the precedence of operators is inherent. It is already taken care of when the prefix notation is written. So if somebody gave me prefix notation, I do not need parenthesization, and there is no ambiguity or confusion on which operator to be applied first, right? The same thing with postfix also. Imagine if somebody gave me the postfix notation, right? So I wrote postfix. Okay, so let me write it as postfix. Okay, when I have postfix notation, for the same thing, how would the postfix notation look like? It would look like this: ABC star plus. Now, what does this mean? So let's try to understand what this means. So I have B and C. In postfix, your operator is right after your operands. So what does this mean? First, I need to evaluate this part, which means B multiplied by C, right? Then I have A and plus, which means this is needed to be added with A. So this is automatically equivalent to this. I do not require anybody to tell me. There is no confusion. So again, there is no parenthesis required. And there is no confusion or ambiguity. When somebody gives me a expression in Infix without the rules of precedence, there is ambiguity, there is confusion that it could be either this or this. And that ambiguity can only be removed using parenthesis. While if somebody gave me in prefix notation or in postfix notation, there is no confusion, right? I do not require parenthesis, and the precedence is already inherent in both prefix and postfix notation. And there is no confusion on which operator which are the operands. There is no confusion whatsoever here, right? So that's the reason why. So you might wonder, why am I learning all of this? Why should I care about Polish notation, reverse Polish notation, all of them, right? So in the early days of computing, right, in the 60s and 70s, right, lot of early computers, and very importantly calculators, especially calculators made by Hewlett-Packard, HP, right? In the early days, lot of early computers and calculators were using reverse Polish notation, which is your postfix notation, right, to evaluate expressions when you give them into your calculators or early computers. They were very popular early on because there is no confusion here. You don't have to worry about the precedence of operators, right? And mathematically, it makes more sense because there is no confusion and precedence is already inherent. Look at the advantages of prefix and postfix. There is no need of parenthesization. Precedence is already inherent, right? And there is no confusion. If somebody gave me an infix expression, first I need to parenthesize it correctly using the rules of precedence like BODMAS, and only then I can accurately evaluate it. So there are more steps involved, right? First, I need to convert from my infix to parenthesized. So if somebody gave me infix, right? From infix, I need to apply my rules of precedence like BODMAS, right? Parenthesize the whole thing, and then I evaluate it. While if somebody gave me the same thing in prefix, there is no confusion. I can directly go ahead and evaluate it. Similarly, if somebody gave me in postfix, there is no confusion. I can directly evaluate it, right? So some of the earlier calculators from Hewlett-Packard and early computers preferred reverse Polish notation, right? And here, because these are popular notations, we will see our stacks being very useful. So our stacks are extremely useful in evaluating your infix expressions. Whether you see, this is possible, right? If somebody gave me a parenthesized infix notation, I can evaluate it using a stack. If somebody gave me a prefix notation, I can evaluate it using a stack. If somebody gave me postfix, I can also evaluate it using a stack. I can also convert from infix to prefix. Similarly, infix to postfix using stacks, right? There are two options. If somebody gave me something in infix, right, I can parenthesize it, use a stack to evaluate it, or I can take infix, I can use stacks to convert them into prefix and postfix, and I can always use stack to evaluate them. Whichever method you use, you're still going to use a stack to evaluate these expressions. This is one of the biggest applications of stacks in day-to-day computing. Your calculators, your computers, wherever there is a calculator, whenever you're doing some simple arithmetic expressions like this, remember that there is a stack sitting behind somewhere which is helping you evaluate this well.